Okay, as I'm going through and creating the other systems, oh, actually, let's stop and pause and look at the system for just a second. So in terms of what's happening over here now, if I look at piping systems, you'll see there's domestic cold water. There is a system that's understood to actually have a lavatory, a urinal, and a water closet in it right now that altogether is going to go ahead and require 32 GPM. So that's a little bit about the flow of the system that's going to be required. And once we have that basically established, as we add more fixtures, the total flow through that system will be understood. Okay. Let me try another one just to give you a similar sort of idea. We'll take that sink and we'll connect it into using that domestic hot water into the domestic hot water line. We'll probably go to the end again. Okay. This has created a domestic hot water system that only has 4 gallons per minute. Let's talk about that. The system that has 32 gallons per minute actually has to have a lot more water flowing through it. Okay, if we want to kind of maintain the same sort of pressure, not have it be incredibly high pressure, what we need is actually a bigger pipe. Okay, and that's what we're going to get to, is really that you can use all this to help you size the pipes. So let me show you to connect the sanitary in, and then we'll demonstrate how that works. So we can go through and, in the same sense, create a sanitary system. Right now there's nothing in the sanitary system. But if I go through and choose, see if I can get the one of these different fixtures. For example, the urinal, and I'll put it into the sanitary system. Okay, it'll tie it in. Notice this time it didn't ask me what type of connection to put in there because there was only one connection left. Same thing's going to happen here with the toilet. As I take the toilet and I say connect it in, since there's only one connection now, the out, or the sanitary out, that'll all be there. It'll connect that in. Okay, and did a pretty good job of that. Let's see now, finally I can get that sink. And I'll connect that into okay, and it's not doing too awfully bad. So overall, once we sort of get past the issue of the capping and keeping the systems maintained to what they're supposed to be, it does a pretty good job of connecting things in here. And over here in the browser, you'll see the different systems are set up so that they're all sort of reporting the right kind of values. So we have some sort of sanitary loads, we have some sort of domestic hot water loads, and some piping loads. So let's stop and just for a second think about if we can apply the same principle that we were applying to the duct sizing to actually take care of the pipe sizing. Because it turns out it really works just the same way. Let me show you what I mean. Okay, let me go ahead and I'm going to take any caps off that are hanging around here, because I do want sort of the notion of the system having some flow. Let me zoom it out again. Now, that pipe ultimately is going to run to some central portion of the building where a main riser for cold water is going to be coming up, or off to a hot water tank, something like that. What we can do now is actually just choose the system. So for example, if I choose the blue pipes, the cold water pipes, and I tab a few times, you'll actually sort of get the whole system. Okay, that's actually right there. That's the domestic cold water system. If you tab, you'll sort of get that. Okay, including the fixtures, all that sort of stuff. And I can go ahead and say, let's use the system inspector and inspect it and start to see what the flow is in each of the different pipes. Actually, just what the information is in here. So you can sort of see the flow direction. Okay, coming all the way through. So 32 gallons a minute, 19 gallons a minute, 15, all the way on down here. Let me cancel out of that. If I choose the pipes, what could I actually do is use something called the duct and pipe sizing. This is very much like the duct sizing calculator. If you choose that, it'll let you, based upon which are criteria, whether you want to do it based on velocity or the friction in the pipes, choose to basically resize the pipe using some industry standard rules. And if you say OK to that, what will happen is those cold water pipes will be resized. Now, just to remind you, when we put them all in there, we put them all in there at 1 inch. Okay, because that is, often a pretty good assumption about the size of those, just based on sort of our intuition and past history. Let's see what it actually comes up with. Doing a lot of flashing around on my system. So I think what it's doing is basically going through and resizing those pipes and kind of changing, and the graphics are updating as we go. Yeah, hopefully on your screen it's not so bad. I think it's a little strange for me because I've got the GoToMeeting recording going on at the same time. That's entirely too much flashing going on. I'm hoping it's going to calm down and stop here in a second. Okay, let's take a look at what it actually did, because it looks like it did. What it's come back with and done is, you can see in this smallest segment of pipe that down towards the end, it's come up with a pipe size of 1 1/4 inch copper. And that's probably sort of maintaining the same up until we get upstream to the point where we have the higher flow necessary to also feed the urinal. In this leg of the pipe, it's 1 1/2 inch copper. As we go back even further upstream, it's 2 inch copper. Okay, so in the same way that we can go through and recapture or recalculate all the different pipe sizes based upon the specific flow needs of the duct sizes, we can do that for the pipe sizes. And that's something ultimately we want to do, is after you go through and route your things together, go through and size things up. So we can do the same thing, for example, with a sewage system. We could choose, tab. I just want the pipes, not the whole system. There we go. We could choose all those sewage pipes, do the same sort of thing. Why won't it do it that way? It's because I have an open capped end on that side. I need to cap that end. I'm just seeing if I can cap a single side of it without having to cap them both. Lots of transitions. There we go. Let's see, you cap a single side without having to get them both. Okay, we could again go for the system inspector. I'm trying to think where, well, I'm going to have to find where the piping calculator is in there. I know on the hot water side, I can definitely do it right there. Duct and pipe sizing, it'll go through and do that. So let me pause there for just a second. What I want to shift to in the last little bit here is actually starting to think about a different type of system and how we can reroute them that way instead. Because, it's actually, well, start just with the whole notion of how you create a gray water system. I'm going to warn you, I have to, I'll be needing to adjourn around 6:30 tonight, because I have to go run off and do something here at work. But let me go ahead and kind of keep on plowing ahead. But before we do that, let's see if there's any sort of questions like on that side. Okay. So are all the pipes made with different sizes, or are they typically sized more uniformly like beams? It's kind of interesting. That's a good question. Often it is fairly customized in terms of as you're moving through a system, they'll go through and keep on trying to optimize them. And it's really all about sort of maintaining a relatively constant pressure in the pipes. So if they can get smaller, they will. And yeah, I don't know why. As opposed to beams where we sort of just tend to choose a few big sizes, piping we actually tend to get to be fairly granular about trying to make them fairly small, or as small as they can be. Save some material. But that's an interesting question about why we don't use sort of a similar approach there. Cool. Okay. Let's go ahead and think about a gray water system for just a minute and really how we might actually go through and model that. Because the truth is, a gray water system is not really all that different from what we've been looking at so far. The idea is, if we want to think about a system being a gray water system, or even trying to create a black water system, all the sanitary sewage is currently going down to a sewer or some sort of system that's going to be taking it away. Ultimately, at the end of the system, we'd have some sort of riser, and it would be taking it off in some direction to go off, in that way, like down to the sewer and ultimately head out of the building. We could think about gray water systems and actually trying to use them to capture some of this water. For example, the lavatory water would be a good one to think about trying to capture the water and reuse it in a different way. And if we want to do something like that, it's actually, not bad at all in terms of trying to set something up like that. Let me kind of show you how you might do it. What I'm going to do is actually just take out the pipe connections. We go to the sink here. Actually, it looks like I took out one too many there. I believe there's one under there. Looks like it's just there. Okay. And I can even take off some of this. Okay, so here's what we're going to do. We're going to redivert the basic drainage from that lavatory or anything that could actually be a source of gray water to a different destination. And here's how we might do that. So we could go ahead and run a pipe. And actually say, oh, I'm not going to give it a system just yet. Maybe I'll do it in 3D from the top. And I'm just going to run it from the back of that sort of area off to another location where we might have some sort of tank. Might be sort of a processing tank. Depends on what we're going to do with the gray water. We're going to recycle it into the building for flushing, whether we need to do any purification to it, just what we're going to do to it. Any sort of filtering. But let's go ahead and put something in there. I'm going to have it slope down. I'll also make it some sort of size, maybe like 2 inches or 3 inches or something like that. And I'm just going to run it outside the building for now, since that'll be a little bit easier to see. Okay, and we're imagining that's going to go off to some sort of place where it's going to do some sort of treatment of the gray water. Zoom on down in here. What I want to do is add that sink to a different system. That sink is already part of a hot water system and a cold water system. It was at some point a member of the sanitary system, but I actually want to go through and take it to a different place. I'm going to delete it right out of the sanitary system. Oops, I actually deleted the fixture. That doesn't look very good. Let's go through and grab that sink again. Keep on getting the pipe around it. And say, what do I want to do? Actually, see if I can do it this way in terms of the pipes over there. I got some pipes. What I want to do is actually go through and create a new piping system. And I'm playing around and sort of struggling a little bit exactly how to do that, because it should be in here, and in terms of the systems, I should be able to, oh, there's piping systems on a different tab. See if I can change anything there. That's not the system I want. That's the overall system. That's the domestic system. What I want to do is actually create a brand new system. And in terms of creating that system, what I tend to think I want to do is actually choose that pipe. But I think the problem is that there's still some sort of connection. Well, let me do something a little bit different. I'll put a new one in there, and that'll make it kind of work. Because again, in the limited time, I just want to sort of like give you sort of a basic way of approaching this. Go back and fix this model and all the things I've done to sort of mess it up a little bit later. So I'll take the sort of wall-mounted lavatory. Put it over there. What I want to do is actually take this guy and say that I'd actually like to create a system for it. And the system that I'm going to create for it, let's kind of choose a system, is going to be a system of type other. I'm actually going to call it a gray water system. Okay, so it's going to want to know in just a moment here which of the different connectors on the lavatory are going to connect into that gray water system. See if it'll, again, I'm having that little graphical goober in terms of displaying it here. There it is. Okay, so what I'm going to do is take the sanitary connector out, say OK, and actually put that into this other system. It's the gray water system. So what I can do now is actually choose this pipe and say that, where is it? Let's choose one of them. I think I have multiple things set up. I'm going to change that to be part of this other system. Okay, and then I can take this guy and connect him from that domestic or the sanitary connection. And connect them into this pipe. Okay, it's a little ugly about what it did there in terms of the routing of the piping, but let's kind of take a look at what it did over here. What it did do over here is now we actually have a lavatory that's understood to be part of the gray water system. So in terms of the total flow and how it's actually going to get computed, it's now considered to be part of the gray water system, and we can use the model to start tracking really how much flow is actually going to go towards that gray water system. Okay, so to complete this, what we'd have to do is basically take that system, and route this to a tank of some type where we're going to go ahead and capture it, do the purification. We can kind of continue with that whole thing on Thursday, or no, next Tuesday, I guess. But really, to get going with it, the big thing is really just to think about really creating another system of pipes that would be called gray water and have those labeled that way so we can kind of compute the flow there. The same thing will actually happen with rainwater in terms of trying to put some drains on the roof, which again we'll kind of look at on Tuesday. It starts with that, and then basically tying the pipes in so they go to a rainwater collection system or stormwater collection system, as opposed to going into the sanitary system. And then we can use the model to go through and compute what needs to happen. So let me pause there and kind of I'm going to get to sort of, I wish I could keep on going further, but let's see if we can kind of answer a last question or two. And I'll point you to a resource for people who want to model a gray water system that may actually help you get started. So any questions? Nope, you're doing pretty good? Okay, then let me go through and show you a place to kind of keep on going just in the last minute here, so you have a sense of really good places you can go to kind of take a look at this, or if you really want to get going with modeling this now. A good thing you can do is, if I just go on out to, and you just even sort of search just for Revit gray water. You'll actually find a really good video that's actually on my BIMtopia site. So it's the same site where I post a lot of the stuff for class. And within that, you'll actually see a video which actually demonstrates a lot of these basic principles. So if you want to start, just get going with putting on modeling a gray water system as part of your design for the building, go ahead and choose this video. And if you do, yeah, it'll walk you through the basic procedure of taking a pipe, reallocating it to the gray water system, and really starting to tag it that way. It's a little YouTube video, about 8 minutes long. It's done in Revit 2009, but the same basic principle still applies. So I definitely highly encourage you to go ahead and take a look at that if you're thinking about gray water systems. The same things would apply to rainwater systems. I guess the final thing we'll show as we're wrapping up today here is really this notion of, let me just kind of leave it there for right now in terms of what's going on. So we can kind of leave it at a good stopping point. I don't want to rush through something in the last minute. So any other last minute questions? Okay, I will apologize for being somewhat scattered and rushing through some stuff today. Hopefully we'll be able to kind of pick up some of this stuff and kind of do it in more detail and actually get it all completed neatly in terms of continuing with this stuff on Tuesday when we are back together in class. But I want to thank you for joining us and kind of putting up with this online way of delivering things. We'll be back to normal next week. And if you have questions or if we manage to confuse things more than we helped, go ahead and we can review the videos or send us some questions. We'll try and get you steered clear in terms of doing those things. But in the meantime, the high level thing to do is just keep plugging away on your buildings, realizing that really 2 weeks from now, we're going to actually be reviewing these things in class. So go ahead and get yourself to a relatively good point with the structure and thinking about with the mechanical systems in terms of the air is going to be moving through there. Think about how the plumbing is going to route through that, because we're going to get this all to a good point where we can share them in class during the final week, during the end quarters period, and hopefully be able to share a lot of good lessons about really our alternative strategies and what you guys came up with for your fantastic design. Okay? Great. Well, let us adjourn then. Thank you very much for attending. Sorry for cutting a little bit short today, but we will be back on campus tomorrow and again next week. Okay? So looking forward to being back together with you.